Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which removes all nodes which don't lie in any path with sum greater than equal to k. First, let us take an example. The sum of all nodes on that path is defined as the sum of the path given a number k. We have to remove all nodes which don't lie in any path with sum greater than equal to k. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 to function prune. Also, let us assume that we have to remove nodes which don't lie in any path with sum greater than equal to 5. So, sum will be equal to 5. Since root is not null, we recursively call the left and right subtrees. So, first we pass the left child of 1 which is 2 along with sum minus roots data using a call stack. Again, as root is not null, we further pass the left child of 2 which is 7 along with sum minus roots data. Since root is not null, we pass the left child of 7 which is null. As root is pointing to null, we return to the previous call and resume execution for node 7. Now we will pass the right child of 7 which is also null. Again, as root is null, we resume execution for node 7. We check if root is a leaf node. Since node 7 does not have both left and right child, it is a leaf node, and we check if root's data is less than sum. Since 7 is not less than 2, the inner if condition doesn't get satisfied and we return 7 to the previous call. Execution for node 2 is resumed and now we pass the right child of 2 which is 8. Again, as root is not null, we pass the left child of 8 which is null. Since root is pointing to null, we return null and resume execution for node 8. Now we pass the right child of 8 which is also null, so root will point to null. As root is again null, we return null to 8's right. We check if root is a leaf node and that root's data is less than sum. Since 8 is a leaf node but 8 is not less than sum, we return root and finish execution for node 8. Execution for node 2 is resumed, and since 2 is not a leaf node, we return root and finish execution for node 2. Execution for node 1 is resumed, and now we pass the right child of 1, which is 3 along with sum minus 1. Again, as 3 is not null, we pass the left child of 3, which is null. Since root is null, we return null to 3's left. Now we pass the right child of 3 which is also null. Again, as root is pointing to null, we return null to 3's right. Execution for node 3 is resumed and now we check if 3 is a leaf node. As it is true, we check if 3 is less than sum. Since it is true, we free the memory for node 3 and return null. Execution for node 1 is resumed, and since node 1 is not a leaf node, we return 1 and finish execution for this program. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.